Chapter 18, quiz. Command and control is a regulatory approach that A, allows the government to own and operate an activity directly. Well, we haven't spoken about this possibility. This is not a regulatory approach. This is a government ownership approach. So, for example, the government buys the power plants and then operates it themselves. They could do that, but this is not what we've talked about. This is not a command and control regulatory approach. B, grants a company the legal authority to participate in a given market. This is not it either. This is closer to the solution, the property rights approach that Coase might have advocated for markets with low bargaining costs. So this is the property right approach, not command and control approach. Attempts to change people's behavior by appealing to their values. No, this is moral suasion. So it's D. States precisely what a polluter must do, including the type of technology to be used. For example, you must decrease pollution by X tons, or you must install this special filter on your smokestacks. Question 2. Suppose that automobile owners pay a monthly fee based on the number of miles driven and the amount of pollutants discharged when the car is running. This would be an environmental policy of emissions taxes, exactly. Because you drive another mile, you pay another penny in tax, or whatever it is. So it's exactly an emissions tax. Here, if you're doing it per mile, you have to, it's not exactly an emissions tax because you're taxing driving, not polluting. It would be better if you had a little reader on the back of everyone's tailpipe and knew exactly how much emissions were coming out, but that's probably a very costly piece of technology. So it's similar, it's almost like, it's the best we could do probably with the current technology. It's not moral suasion, it's not these other ones. You could imagine a permit pollution control system for driving, where if you didn't drive that much, you could sell your permits to someone else, but that's not what we're talking about here. Command and control would be you can only drive X miles per day.
And then your car turns off.
Say again?
And then your car turns off.
Right. People generally, are hesitant to let the government monitor their driving and so on and so forth. So, in fact, in reality, what we do is we tax gasoline consumption, right? And so, when all cars had roughly the same miles per gallon, that was, almost the same exact thing as taxing driving. But now what we see is that some cars are electric, right? And so, this has a couple of problems. So not only are some cars electric, some have really low MPGs. So this is good, but also it has some problems associated with it. For example, it doesn't do anything for congestion, right? Because the gasoline tax discourages driving and lowers congestion. But if you don't pay the gas tax because you have an electric car, you're going to not be discouraged and congestion might be worse. Also, then the government doesn't raise money. And a lot of the money raised through this gas tax is used to fund improvements to roads and transit and so on. So this is an issue transportation people are working on now. But anyway, question 3. If this market produced blank units, then blank. Well, you can kind of get a sense of what we're looking for here. It's efficient, total cost equals total benefits, or what's the marginal cost? So let's try them one at a time. 30 would be efficient. Is that true? 30? Marginal benefit equals marginal cost, so yeah, that's efficient. But let's go through these other ones just to make sure. At B, 30 marginal benefit is greater than marginal cost? No, they're equal. At 45, total cost would equal total benefits. So at 45, how would we find total cost? If we have 45 units of emissions. So remember, this is the marginal cost curve. The area under it is total costs. So in other words, here are total costs. These are total costs. What about total benefits? Well, it's the area under the demand curve. And it looks like the demand curve probably goes like this, but it's not drawn all the way, right? So we might assume that it just goes like this. Or maybe there's just no demand at all for 0 to 20, but that doesn't make much sense. So it's hard for us to say. You might say it's like, these are total benefits. If that's the case, then clearly, the blue triangle is much bigger. So this is potentially a right answer, But given we don't have enough information to really say, because the demand curve just kind of stops there, I wouldn't advise you to select that one, especially because A is clearly right. And this is clearly wrong. At 45, marginal costs are 25, not 0. Okay, question 4. If the level of emissions is R, or right here, then efficiency is achieved by, well, first of all, let's just not look at the answers and say, what would you say? It's achieved by increasing pollution, right? Because we're not polluting enough. We're restricting some activities, for example, maybe driving, that would bring people a lot of benefits, and we would like to let them do that, right? It's not that we want pollution for pollution's sake, but we want them to do those activities that unfortunately generate pollution. So, not A, because we do want to increase the level of emissions. What about decreasing abatement efforts? Well, if abatement means reducing pollution, we want to decrease the amount by which we're decreasing pollution, so that's right. So in other words, we want to decrease abatement efforts. We want to increase pollution. So this is the right answer. Increasing abatement efforts would mean we go even further back. And decreasing the level of emissions, again, would mean we go further back. So only B is the right answer. 5. If it costs motorists $1 to reduce carbon monoxide emissions from 10 pounds to 9 pounds, and $3 to reduce them from 9 pounds to 8 pounds, the marginal benefit of the 10th pound of carbon monoxide is A, $1. So I didn't really talk about this in any of the lectures. If you read the book, you would know. It has to do with this last question, question 4. So let's go back to this figure for a moment. If you read it from left to right, then we think about it as increasing pollution or decreasing abatement. But if you read it from right to left, you think about it as increasing abatement, as we go this way. And so it's the two sides of the same coin, right? Because the benefit of clean air, how should I say this? The benefit of clean air is the cost of abatement, right? You know, I think I'm going to edit that part out. So just read that section of the book. I did the same thing with the international trade chapter, and I had to fix that in the video. And the reason was I was trying to think back to the, let me tell you this later. Let me finish this up first. Okay, question 6. Pollution is defined as, A is the answer, right? So we just read that a moment ago. And the key, again, as I said in the lecture, is pollution is anthropocentrically defined, right? So it's only if it harms humans is it considered pollution. This is not the way that all people see pollution, but this is the economics approach, right? Some economists see things, you know, are able to look at the world through multiple lenses, not only through an economics approach, but also through maybe an ecological approach or, you know, social justice approach. But in the economics approach, we're talking about the anthropocentric definitions of pollution. Okay, 7. Markets allocate resources blank when the blank confronts the decision makers with the blank and blank of their decisions. So if you look at these words, markets allocate resources inefficiently, price system costs benefits. Well, I hope that you all got C. It makes sense that we would be talking about how it allocates them efficiently. So let's try that one. Efficiently. Markets allocate resources efficiently when the price system confronts decision makers with the costs and benefits of their decisions. And so we've seen that in the case of pollution taxes. If you don't have to pay a tax for your pollution, then you just pollute as much as you want. But once you start paying for it, then you're confronted with the cost of it. Not only the benefit of driving, say, but the cost of polluting also. And so that's the point. And more generally, it is a property of markets, not only for pollution, but for anything. Right? If we're talking about how do we allocate pizza, you know, we don't just randomly distribute pizza. We say who wants to pay for the pizza, right? That's the cost of it, and then people who are willing to pay that price get it. So the price system really is the key to the invisible hand that we talked about at the beginning of this course. And it's the price system that does that. And that's why many of the incentive approaches and approaches to policy, environment, transportation we talked about in this lecture have to do with the price system. Okay, question 8. If there is neither too little nor too much pollution, in other words, the Goldilocks level of pollution, the level of emissions per period will be blank, and the market is blank. Well, if it's Q, it'll be efficient. So D is the right answer. Question 9, I asked you to skip this one because we did not read this case in point article. It's from a different edition. And then question 10, easy. Moral suasion is appealing to a sense, B, appealing to a sense of moral values to change people's behavior.